Another interesting behavioral design pattern is Memento. So the Memento design pattern provides an ability to restore, roll back, object to its previous state. So the problem to solve here is pretty obvious. We would like to consider some sort of item in the system that has considerable hidden state information, and presumably the state is very important. So it could be our legal obligation to preserve a certain state. A good example of this could be an investment account or bank account. So the client, the rest of the software that uses the item class, wants to remember states and modify the states. And although this appears as a single bullet on this specific slide, the modification of state of this item could be composed of multiple stages. So we could have a little bit of an update made and then do some checks, and we can do more updates and do some kind of other checks or validations. And at some point, we may decide that this cannot succeed. And then we would like to optionally be able to restore the state back to the original checkpoint state which we remembered at the very beginning. And while doing all of this, the class item here, consider this to be like a banking account with its balance, already is designed. And now we're thinking of this rollback, of this restoration of its previous states, and we absolutely want to have the minimal impact on the original design of this class that would like to be able to preserve the state information. So let's take a look at the structure. So this is the structure of the Memento design pattern. And of course, what we have here is the Memento class, and we have the originator. So the originator is actually the object with state. So the idea is pretty simple. The system wants to be able to modify the state of the originator. And at the same time, we would like to be able to preserve the state and be able to restore the state. So to preserve the state, we have this create memento. So this create memento will basically create an instance of this object. This is not UML, I'm just doing the demonstration here. And if we would like to restore the state that we preserved, then we have an operation named set memento. So we can basically use this operation to be able to restore the state. So in addition to this, in this structure, what we have is that we could proceed through a complicated transaction, which may have to update the state in multiple stages. And therefore, at multiple stages, we may have to generate these memento instances. So, of course, we need to preserve a collection of these mementos. And what we create here is the caretaker. So the responsibility of the caretaker is to, of course, preserve the mementos. So it simply stores array, collection of memento objects. And at the same time, it provides the undo mechanism or rollback mechanism. So basically, we can have this caretaker. We could give it the originator, the reference to the originator, and ask to restore it to the original state. So we can have, so we basically will be using then these memento instances to do this rollback. I also would like to note that the state inside the originator, like banking account, and inside the memento, which is this banking account copy, basically copy of its state. These two states are oftentimes exactly the same. So it's possible to create the originator state class, okay, and move all of these state fields out to a separate class, and then have both of these inherit, right? Both of Memento and the originator inherit the state from the base class, right at the top of this hierarchy. In fact, I would consider this to be a better version of the Memento design, so that we don't have to repeat the same fields in here and here, right? So instead, we can just move the state into the base class and simply inherit it from the base class in both the originator and the Memento class design. So we have a Java example of Memento structure. And we have this sample in our set of UML diagrams that we used in our design patterns videos, and we obviously continue using it. So right here is the sequence diagram for using a Memento design pattern. And so here let's just quickly go through the sequence. And so what we have here is that we have this main app class, which contains the operation named main. So the main operation, of course, is the demonstration of the Memento design pattern. And so let's just increase the size of this a little bit to make it more readable. And so first what happens is that we construct checking account. Right, so this checking account object is constructed inside the main first. And then obviously we're just about to attempt some sort of transaction on this account. So we call checking account create memento operation. And this create memento in turn constructs the account memento object, which is then given to the account caretaker to store. I'm assuming that the account caretaker also can be constructed part of the transaction class, or as a standalone class, or it could even be some sort of singleton class in the system. But anyway, we have access to it. And once we generate mementos, so here we take a snapshot from the account, from the checking account, and by calling create memento, and we construct it and we give it to the caretaker to store. And now transaction proceeds to withdrawal with the initial state of the checking account already preserved. So we're going to treat this operation as a transaction which may either succeed or fail for various reasons. For instance, because there could be insufficient funds, there could be fraud detection, there could be maybe no cash left in the cash dispenser equipment at the ATM machine, and so forth. So what we do is that as we begin this withdrawal, we check the available balance through checking account get balance operation. We apparently update the balance here. Once the balance amount is changed, we remember the checking account state again by calling create memento. And so this again constructs another copy of account memento, which is not shown on this diagram. And we can definitely pass this new memento to the account caretaker. So we could insert another copy of the checking account state into the account caretaker collection of the mementos. And later on, we'd like to demonstrate the scenario of undoing this withdrawal, undoing this transaction, or rolling it back completely as if it has never been attempted. So what we do, we call account caretaker undo or rollback would be another name for this operation. So the checking account restore memento is invoked. Basically, the caretaker looks up instances of account mementos, pulls them out of the collection, and gives it to restore memento of the checking account. So this is support on the checking account side of our design to be able to restore the state. Okay, so this is what it does. So we ask account memento this time to get the balance. And of course, we pass the balance amount to the checking account to restore memento, and we repeat account memento get balance for each memento object present in this transaction. So ultimately, we should be able to restore the original checking account balance to its original amount, which brings transaction rollback to an end, completely undoing all the changes that were done at earlier stages. Of course, undoing the changes is totally optional. So this portion of this demo is completely optional because it only demonstrates the possibility of rolling back the transaction just in case where it's really needed because we have some sort of problem encountered in the middle of the transaction where some changes have already taken place.